Hello. In this video, we're going to continue our study of the unit circle. Is root 3 over 2 1/2 on the unit circle? How about 1, 1? How about 0.6, 0.8? How would you know? What we need here is an actual function for the unit circle, or at least an equation. Because if you remember, we drew the unit circle like this, and we said it had a radius here, a radius of 1. But how do you make a circle? What kind of function, equation, relation creates a circle? Let's go ahead and just take some guesses. We'll go on Desmos here and we'll see if we can create ourselves a circle. Okay, let's try maybe x. That doesn't do it. Maybe x squared. That's not really a circle. I mean, it's got a curve to it, but that's a parabola. Maybe you could like add a number, maybe like +1 because there's a radius of 1. That's not really working. Let's think about the circle. If you remember, a lot of the circle we kept using Pythagoras, right? For doing the missing side. It's like a squared plus b squared equals c squared. Well, the a squared is the x side, so a squared would be x squared, and b squared was the y side, so maybe we could put a squared plus b squared equals c squared. I mean, the radius is 1, maybe c squared. Oh, whoa, look at that. We have ourselves a circle. It appears like the equation x squared plus y squared equals 1 squared creates the unit circle. Okay, this is pretty awesome because if we have an equation, we can now use it to check for points. Let me show you what I mean. Since we know that x squared plus y squared equals 1, we can take this point, which is an x and a y value, and we can plug it in to the equation. So we would get root 3 over 2 squared plus 1 over 2 squared, and that should equal 1 squared. Well, root 3 over 2 squared, we have to square the top and bottom. Square root of root 3 is just 3. Square root of 2 is 4. Square root of 1 is 1. 1 plus 3 is 4. Yeah, we get 1. 1 equals 1. So yes, this point is on the unit circle. And I mean, you might have noticed that. You might have said, oh, I know this point's on the unit circle. I remember. This is the point right here, root 3 over 2 and 1/2. This is the point when theta equals 30 degrees, or pi over 6. And I would say, yes, it does. We memorize that point, but it's nice to be able to show how that point is on the unit circle using an equation because it allows us to do some other checks. For example, the point 1, 1. Is that on the unit circle? Well, we would take 1 squared plus 1 squared. That'd be 1 plus 1. That's 2. And that's not equal to 1. So this is clearly not on the unit circle. And again, well, you might say, well, Mr. Peters, I kind of knew that. I mean, the point 1, 1, right? That would be like over here. That doesn't look like it's on the unit circle. Plus, it's not one of the points I memorized. And I would say, okay, well, sure. But what about a point like this? 0.6 and 0.8. Now, that's not one of the values, right? That's not a root 3 over 2, a root 2 over 2, a 1/2. It's not one of the ones we memorized. But is it still on the unit circle? Well, let's try it. It might be easier to write these as fractions. So this is 6 over 10, and this is 8 over 10, which we could simplify as 3 over 5 and 4 over 5. Okay, so let's plug that in. 3 over 5 squared plus 4 over 5 squared. That's going to be 9 over 25 plus 16 over 25, which is 25 over 25, which is 1. So yes, this point is on the unit circle. It's a point that's on the unit circle. Looks like it's kind of, I don't know, maybe over there-ish. We don't know the exact angle because this isn't one of our key points that we memorized. But if you think about it, a circle has an infinite number of points. There's an infinite number of points on this unit circle. And we just memorized a few of them, the ones that we found that were really useful for doing our trig work. But there are other values on the unit circle, for example, like 0.6 and 0.8. They're not worth memorizing because they don't really come up that much. But they are on the unit circle. They're one of the infinite points that are on there. And we can check that by using this equation. Now, of course, by saying there's an infinite number of points on the unit circle, I have to be careful here. There's also an infinite number of points that are not on the unit circle. And so, again, the way we know is by plugging it into the equation. So which of the following points are on the unit circle? Go ahead and go through these 5 points and see which ones are and which ones are not. So pause the video and give it a try. All right, so let's put that equation again here. X squared plus y squared equals 1. And we're just going to go through these one at a time. So root 2 over 2 and root 2 over 2. We might know already, yes, this one works because it's one of the points that we memorized. But we should check it. Root 2 over 2 squared plus root 2 over 2 squared. That will be 2 over 4 plus 2 over 4. 4 over 4, which is 1. So yes. Okay, how about root 3 and root 3? Well, root 3 squared. Root 3 squared. Oh, I'm not feeling good about this. This will be 3 plus 3, which is 6. Not equal to 1. So, no. All right, let's try this weird one. 3 over root 15? My goodness. Negative root 6 over root 15? Okay. Well, when we square the square root, it goes away, so we get 9 over 15. When we square the negative, it goes away, so 6 over 15. Oh, that's 15 over 15, which is 1. Yes, this point is on the unit circle. Strangely enough. Okay, negative 1 and 1. Negative 1 squared plus 1 squared. 1 plus 1 is 2. Yeah, that's not working. That is not on the unit circle. And finally, 5 over 13 plus 12 over 13. That's going to be 25 over 169. 144 over 169. Oh, well, that's 169 over 169, which is 1. So yes, that one is on the unit circle. Okay, if we know the point x and 5 over 6 is on the unit circle, let's determine all possible values for x. In other words, we know that this equation is going to work. We know x is just x. And we know y is 5 over 6. Can you solve for all possible values of x? Go ahead and pause the video and give it a try. All right, so what we have here is x squared plus 25 over 36 equals 1. X squared equals 1 minus 25 over 36. So that would be 36 minus 25 over 36. That's going to give us 11 over 36. Now to solve this, we'd square root both sides. And we get x equals plus or minus root 11 over 36. Now it's kind of nice to make this 11 over 6 because the 36 does square root nicely. So we have two options. X equals positive root 11 over 6, and x equals negative root 11 over 6. And we want to make sure that we state both of these answers because it says determine the possible values. Look at that S. Sometimes in math we have multiple solutions. This is one of those situations, and we want to make sure we list both answers. If you think about it logically, on the unit circle, we're looking for a point where we don't know the x, but the y is 5 over 6. Well, in other words, the y is just before the 1. And we can see here that there are two solutions, one with a positive x and one with a negative x. So even visually, we should see that there's definitely two solutions here. So we don't want to miss that negative one. Let's do another question. If we know the point blank over 25 is on the unit circle, determine some possible values for the top of the fractions. No, we're only going to use whole numbers here because this is like a little puzzle. So pause the video and give it a try. All right, you might have been able to come up with a bit of a silly value. This is one that often jumps out to me. 0 over 25 and 25 over 25, because that would just be 0, 1. And that's definitely on the unit circle. But were there other values you were able to find using whole numbers? You might have found 15 over 25 and 20 over 25. Now, why does that work? Well, again, if we do 15 over 25 squared plus 20 over 25 squared, 15 squared is going to give us 225. 25 squared is going to be 625. 20 squared is going to be 400, and again over 625. So that's 625 over 625, which is 1. So this definitely is on the unit circle. Now again, this is just a bit of a puzzle, a little bit of problem solving here, so don't worry too much if you weren't able to get another one after this. But if you were really working at it, there is one more that I was able to find anyways. It was 7 over 25 and 24 over 25. This one's kind of fun, right? When we do this, we would check the 7 squared, which is 49, the 24 squared, which is 576. So 49 plus 576, just kind of skipping the details here, would give you 625. And this is our 7 squared, this is our 24 squared. And then that's going to give us the 625 over 625. All right, so these 3 are on the unit circle. Now, there might be more out there. These were the 3 that I found. And if you found others, feel free to leave it in the comments below. But let's go ahead and do a couple more questions. Okay, let's try another one. If the point 5,9 exists on the terminal arm of an angle in standard position, determine the coordinates of the corresponding point on the unit circle. Okay, this is a pretty weird question. So let's see if we can try to get a handle on it. We're going to draw a circle. And this is like a unit circle. Okay. And there's supposed to be a point. So 1, 2, 3, 4, 5 is maybe over here. Maybe 9 is up here. So here's the point, 5, 9. And this point exists on the terminal arm of an angle in standard position. In other words, we draw a line, right? This is a point on the arm, okay, of an angle. And we're supposed to find the corresponding point on the unit circle? Well, the corresponding point, that means kind of over there. The point on this arm that corresponds to the unit circle. Okay. Let me think about this. How could we find that point? Well, we know that this is a line, and we know that over here the point is 5, 9. Well, that point's not on the unit circle because 5 squared plus 9 squared, there's no way that's going to be 1. But somewhere over here we should have some x squared plus y squared that does equal 1. And it should be kind of like a 5 and 9, right? It should sort of be like a 5 over something plus a 9 over something. And then when we square those, we should get 1. Well, what did we have over here? We had 5 squared plus 9 squared. And that was definitely too much. Maybe let's calculate it. 5 squared plus 9 squared would be 25 plus 81, which is 106. That's way too big, right? We need to just get 1, not 106. So let's divide both of these by 106. Well, okay, but we got to be careful because there's a square happening. So let's divide them by the square root of 106. Well, that's going to give us 25 over 106 plus 9 over 106. Plus 81. 81 over 106. Well, that'll add to 106 over 106, which is just 1. Okay, so the corresponding point over here is 5, 9. It is like a 5, 9, but it's been shrunk down by the square root of 106. Shrunk down by the square root of 106, or divided by that, so that it's actually where it needs to be on that unit circle. So if you're wondering again for a bit of a technique here, you basically figure out what you have, but you're supposed to get a 1, and so you divide the coordinates by the square root of 106 to shrink them down. All right, let's go ahead and take some notes on this. So here we are working with the equation of the unit circle. So that's our new concept that we learned today. We learned that it's x squared plus y squared equals 1. And I mean, that's about all there is to it. So let's do an example. Justify if 1/4, 3/4 is on the unit circle. Justify whether or justify if 1/4, 3/4 is on the unit circle. So pause the video and give that a try. All right, so for a solution here, we could take 1/4 and square it, 3/4 and square it. It's going to give us 1/16 plus 9/16, so 10/16, which is not equal to 1. So no, not on the unit circle. All right, for some extra practice, you can look at worksheet 8 and 8.5. And then you can write down any things to remember. Probably the thing I would remember on this question, and these types of questions in general, is that if you're solving x squared plus y squared equals 1, don't forget the plus minus. I've sometimes seen students just find the 1 value when there are often going to be the 2 values, the plus and the minus. All right, hopefully you enjoyed this video, and as always, thanks for watching.